Welcome everyone. In today's class we will discuss about redox reaction. This is the part 1 of this chapter. In this part we will learn the redox reaction, that is what is basically the redox reaction, the spectrochemical cell, how the spectrochemical cell can be represented and how it is related with the redox reaction, overall its objective, and then finally we will calculate the E0 cell, and we will come to know that what is the basic importance to calculate the E0 cell and what is its application. So first we will learn what is basically a redox reaction. So this term redox is coming from two words. Okay, this red is coming from reduction and this ox is coming from oxidation. So this redox reaction is basically the combination of reduction and oxidation reaction, or you can say that a redox reaction is that kind of a particular reaction where reduction and oxidation process are going simultaneously. মানে একটা রেডক্স রিঅ্যাকশন বলতে ওভারঅল এইটা বলতে পারো যে একটা রেডক্স রিঅ্যাকশন মানে যেখানে রিডাকশন আর অক্সিডেশন দুটো একই সাথে হচ্ছে, মানে সাইমালটেনিয়াস প্রসেস হচ্ছে। একটা অ্যাটম অথবা আয়ন হয়তো রিডিউস হচ্ছে, সিমিলারলি ঠিক একই জায়গায় একটা অ্যাটম অথবা আয়ন তার অক্সিডেশন হচ্ছে। হোয়াট ইজ বেসিক্যালি দ্য অক্সিডেশন? দ্য অক্সিডেশন মিনস দ্যাট losing of electrons. What is then basically the reduction? Reduction means that it is the gaining of electrons. Okay, মানে অক্সিডেশন কি যেখানে অ্যাকচুয়ালি ইলেকট্রন ছেড়ে দিচ্ছে, রিডাকশন কি যেখানে ইলেকট্রন গেইন করছে অথবা অ্যাকসেপ্ট করছে। or in other words you can say that oxidation means that change of lower oxidation state to higher oxidation state, that is basically named as oxidation. And reduction means that change of higher oxidation state to lower oxidation state. So this is basically the definition of oxidation and reduction reaction, and where the oxidation and reduction reactions are occur simultaneously at the same time, then that kind of reaction can be named as a redox reaction. So I think that you are the things of redox reaction or the definition of redox reaction is now clear to you. Now we'll move to some examples to have a more clear picture. So basically we are taking an example of a redox reaction. Say for example zinc is reacting with copper sulfate and being converted into zinc sulfate plus copper 2+. Okay, copper 2+. So now we want to look into this whether it is a redox reaction or not. So this is basically can be converted into an ionic form. So what is the ionic form? Ionic form is zinc plus copper 2+, which is being converted to zinc 2+. This would be copper. Okay, this is by mistake, zinc 2+ plus copper. Okay, so now why we are writing this as copper 2+ and zinc 2+? Say for example in this copper sulfate the oxidation state of copper is +2 and the sulfate is being -2 charge, whereas similarly in case of zinc sulfate, zinc has the oxidation state of +2 and the sulfate would have a -2 charge. So therefore the ionic equation can be converted into zinc plus copper 2+ to zinc 2+ plus copper. So what is basically the reduction and what is basically the oxidation reaction? We have to find that out in the step 1. So now here the zinc is being converted to zinc 2+. So basically this is the oxidation reaction, and this copper 2+ is being converted to copper. So basically this is a reduction reaction, right? So basically this is the reduction and the oxidation process is zinc is being converted to zinc 2 plus. So basically there are these two process which is named as oxidation and reduction process, and this is the step 1. And the step 1 is basically that how to represent a redox reaction. So basically, to represent a redox reaction, you have to write the reaction and then you have to point out the oxidation and reduction process, like in this case where zinc is being converted to zinc 2 plus, that is basically the oxidation process, because its oxidation state is changing from a lower to higher oxidation state, or from 0 to plus 2 oxidation state. And the reduction process is from copper 2 plus to copper 0. Why? Because the oxidation state is changing from a higher to lower side, or the oxidation state of plus 2 is being changed to 0 state. So this is basically the step 1, which is actually explaining how to represent a redox reaction in the ionic form. So when we will go to just explain the mathematical term, or when we will have some application of this redox reaction, then we will have to do the math, or we will have to do the application step by step. So in that case actually we'll have these redox reaction, or we will have to write the redox reaction as per this procedure, which is actually named as, or which is actually referred as step 1. Okay, so now we will learn the electrochemical cell and how it can be represented, or how it is actually related with the redox reaction. So now we are taking the same example. For example, that is zinc plus copper 2 plus, or you can say that zinc plus copper sulfate, which is being converted to zinc sulfate plus copper. So again you can convert it as zinc plus copper 2 plus, which we have already seen in the last slide, and this is zinc 2 plus plus copper, and we have come to know that this is basically the oxidation reaction and this is basically the reduction process. Okay, so this was the step 1. So now it would be a step 2. It would be a step 2 to write the electrochemical cell, or to represent the electrochemical cell properly. Okay, so now an electrochemical cell is represented by a salt bridge in the middle of that cell. So this is the salt bridge. The left hand side is actually the anode, where the oxidation process is being carried out, and the right hand side is actually the cathode, where the reduction process is actually being carried out. So now in our example, what is the oxidation process? So the oxidation process is that this zinc is being converted to zinc 2 plus, right? So this is the oxidation process. The zinc is being converted to zinc 2 plus. So left hand side is the oxidation. So we will represent the left hand side in such a manner which looks like an oxidation process. Okay, so we'll write this as zinc by zinc 2 plus. We'll not write it as zinc 2 plus by zinc. Why? Because it represents the reduction process. So left hand side is the oxidation process. First we will point out what is the oxidation process, and the oxidation process will be represented in such a way so that it will truly look a oxidation reaction. Okay, similarly in the right hand side, as it is a reduction reaction, we have to point out the reduction reaction first. So the reduction reaction is a copper 2 plus is being converted to copper 0. So in the right hand side we will write the term in such a way so that it will truly represent the reduction process. So in the right hand side we will represent it as copper 2 plus by copper. Why? Because it is actually reduction process. So we should represent in that kind or in that way. Therefore we cannot represent it as copper by copper 2 plus. তাহলে ওভারঅল জিনিসটা কি হলো, যে সেকেন্ড স্টেপ হচ্ছে আমাদের প্রথম স্টেপ হচ্ছে আমাদের যেরকম আমরা একটা রেডক্স রিঅ্যাকশন আমরা দেখছিলাম যে কিভাবে আমরা অ্যাকচুয়ালি লিখবো এবং কোনটা অক্সিডেশন কোনটা রিডাকশন প্রসেস সেটাকে আমরা আইডেন্টিফাই করব। তারপরের কাজ হচ্ছে আমরা ইলেকট্রোকেমিক্যাল সেলটাকে লিখবো অথবা ইলেকট্রোকেমিক্যাল সেলকে আমার ড্র করতে হবে। ইলেকট্রোকেমিক্যাল সেল যখন ড্র করব মাঝখানে আমার থাকবে সল্ট ব্রিজ, আর ইলেকট্রোকেমিক্যাল সেল যখন আমরা লিখবো তখন আমাদের মনে রাখতে হবে যে ইলেকট্রোকেমিক্যাল সেল লেখার সময় আমাদের সবসময় ওটাকে আয়নিক ইকুয়েশনে লিখবো। এভরি টাইম we should write the equation in the ionic form prior to draw the electrochemical cell, otherwise it will be a problematic situation. তাহলে প্রথম আমরা কি করব, ইলেকট্রোকেমিক্যাল সেল ড্র করার জন্য মাঝখানে আমরা যেটা লাগছি দুটো প্যারালাল লাইন, সেটা হচ্ছে একটা সল্ট ব্রিজ, বাঁদিকে হচ্ছে আমার অ্যানোড যেখানে অক্সিডেশন প্রসেস হয়। অক্সিডেশন প্রসেসটাকে আমরা অলরেডি আইডেন্টিফাই করেছি যে জিঙ্ক থেকে জিঙ্ক 2+ কনভার্ট হচ্ছে, তাই ওখানে আমরা লিখবো ওরকমভাবে জিঙ্ক বাই জিঙ্ক 2+, কারণ ওটাকে আমরা অক্সিডেশন দেখাচ্ছি। সেখানে কিন্তু জিঙ্ক 2+ বাই আমরা জিঙ্ক একদমই লিখবো না, তাহলে সেটাকে রিডাকশন দেখানো হবে। ডান দিকটা কি হলো, ডান দিকটা হচ্ছে আমার রিডাকশন প্রসেস ইন ক্যাথোড, তাই ডান দিকে আমার রিডাকশন যেহেতু প্রসেস হচ্ছে আমরা রিডাকশন প্রসেসটাকে আগে আইডেন্টিফাই করবো যে কপার 2+ থেকে কপার হচ্ছে, তাই আমরা ডান দিকটাকে সেরকম ভাবেই লিখবো যাতে সেটা দেখলে মনে হয় রিডাকশন, তাই আমরা সেটাকে লিখবো কপার 2+ বাই কপার। আমরা কিন্তু কপার বাই কপার 2+ কখনোই লিখবো না, কারণ কপার বাই কপার 2+ হচ্ছে এক ধরনের অক্সিডেশন স্টেপ, অথবা দেখলে সেটাকে অক্সিডেশন মনে হবে। Okay, so in the next slide we will learn about the objective of this E0 cell. So the primary objective of this E0 cell to calculate the E0 cell value or the calculation of this cell potential. Okay, so basically that E0 cell is actually related with this free energy change del G0, because del G0 can be represented as minus NFE0 cell, where N is the number of electron transfer and F is the Faraday constant and E0 cell as the cell constant or the value of the cell constant or the electron potential. What we actually calculate, that the E0 cell value, we will have to calculate it through the redox reaction. We will come to this later. Okay, so now this E0 cell can be a positive term or the E0 cell can be a negative term. Now this E0 cell, if it is positive, then the del G0 would be definitely negative, and now if E0 cell is negative, then del G0 would be positive as per this equation, that del G0 equals to minus NFE0 cell. Now we know as per the basic chemistry that the del G0 represent or the G is represent the spontaneity of the reaction. Now when the del G0 would be negative, then we can say that it would be a spontaneous process. It would be a spontaneous process, right? And when the del G0 would be positive, then it would be a non-spontaneous process. Non-spontaneous process. So I think that we have already know what is the main objective. The objective is to calculate the E0 cell, and why it is important, because through the E0 cell we can explain whether the reaction will be a spontaneous reaction or not, because if the E0 cell value would be positive, then we can definitely say that through the equation of del G0 as it is equals to minus NFE0 cell, then it would be negative and therefore the reaction would be spontaneous. And now if the E0 cell would be negative, then as per the equation del G0 would be positive and it would be a non-spontaneous process. So this is basically the importance of E0 cell calculation, and this is actually the step 3 or overall process. So the step 1 was how to represent the redox reaction in ionic form. Second one was to draw the electrochemical cell in a proper way, and third one was the E0 cell calculation. So this is basically the theory of this E0 cell calculation. You can take a note of this. And finally I want to say that to represent the E0 value or the standard potential, it can be of two ways. Okay, say for example you can represent a system like this. This is a copper 2+ by a copper, which can be represented as 0. Or which the value of this as 0.34 volt. So this is basically the reduction potential. Why it is the reduction potential, why it is named as the reduction potential? See, the E0 value is copper 2+ by copper, right? So the copper 2+ is being converted to copper, so it is basically reduced, so therefore it is named as reduction potential. And it can also be represented in the terms of oxidation. So the copper will be converted to copper 2+, and then the value would be just just the opposite of reduction potential. So if the reduction potential would be positive, the oxidation potential would be negative. Now it is named as oxidation potential. Why? Because the copper is being converted to copper 2 plus. So just look at this thing carefully, because in the next slide we will do some math in which actually we will require this type of term. তাহলে ওভারঅল যে E0 যে ভ্যালুগুলো আছে, মানে স্ট্যান্ডার্ড পোটেনশিয়ালের যে ভ্যালুগুলো আছে, সেই ভ্যালুগুলোর ক্ষেত্রে আমরা দু ধরনের ভ্যালু পেতে পারি, একটা রিডাকশন পোটেনশিয়াল পেতে পারি, একটা অক্সিডেশন পোটেনশিয়াল পেতে পারি। ইন কেস অফ রিডাকশন পোটেনশিয়াল, if the value would be positive, in case of oxidation potential the value would be negative. মানে রিডাকশন পোটেনশিয়ালে যে ভ্যালু পাবো, অক্সিডেশন পোটেনশিয়ালে ভ্যালু তাই পাবো, শুধু সাইনটা অপোজিট হয়ে যাবে। এটাই হচ্ছে রিডাকশন আর অক্সিডেশন পোটেনশিয়ালের মধ্যে পার্থক্য। রিডাকশন পোটেনশিয়ালটাকে আমরা এমন ভাবে লিখছি দেখলে রিডাকশন মনে হবে, অক্সিডেশন পোটেনশিয়ালটাকে আমরা এমন ভাবে লিখছি দেখলে অক্সিডেশন মনে হবে। বাট দ্য মেইন অ্যাসপেক্ট টু শো দিস টাইপ অফ টার্ম ইজ দ্যাট the reduction potential is nowadays is in general accepted and the oxidation potential is not. So whether so in our next slides, when we will do some math or when we will do some applications, we will only consider the reduction potential value, we will not consider the oxidation potential value. যদিও অক্সিডেশন পোটেনশিয়াল ভ্যালু আমাদের দেওয়া থাকে, উইল কনভার্ট ইট ইন দ্য রিডাকশন পোটেনশিয়াল ভ্যালু, কারণ আমার সাইনটাই শুধু চেঞ্জ করলে হবে। তাহলে ফার্দার এরপরে যে ইকুয়েশনই হবে, আমরা সব জায়গায় রিডাকশন পোটেনশিয়াল ইউজ করব, আমরা অক্সিডেশন পোটেনশিয়াল ইউজ করব না। কিন্তু অক্সিডেশন পোটেনশিয়াল ইউজ করলে সেখানেও কোনো ভুল নেই, তোমরা অক্সিডেশন পোটেনশিয়াল ইউজ করেও অঙ্কটা করতে পারো। বাট অ্যাকচুয়ালি রিডাকশন পোটেনশিয়ালটা ইউনিভার্সালি অ্যাকসেপ্টেড এবং ওটা দেখানোই যেহেতু ভালো, তাই আমার সাজেশন হচ্ছে অক্সিডেশন পোটেনশিয়াল না ইউজ করে রিডাকশন পোটেনশিয়ালের মেথডেই সব অঙ্ক করো, এবং একটা মেথডে করা থাকলে তাহলে সেখানে গুলোবে না, শুধুমাত্র রিডাকশন পোটেনশিয়ালই মনে থাকলেই সেটা হবে। ওকে, সো নাও ইন দিস কেস we will try to figure out how to calculate the E0 cell. Suppose in the case in our previous case we took an example like zinc is reacting with copper sulfate, so copper 2 plus to be converted into copper plus zinc 2 plus. So basically there is the oxidation and reduction process. So now it was a step 1, right? And the step 2 was zinc by zinc 2 plus in the left hand side, that is the anode side. Middle one was the salt bridge, right? And the right one was the copper 2 plus by copper. This is basically the cathode where the reduction process is going on. So now here we will do the step 3. So step 3 would be the E0 cell calculation. So how we will calculate the E0 cell? So the basic equation to calculate the E0 cell is E0 reduction, that is the rate for reduction of right hand side, that is the R, or you can say RHS, that is the right hand side, minus E0 reduction, RED for reduction, E0 reduction of left hand side. So now what is the E0 reduction of right hand side? So what is the right hand side? This is the this is the right hand side, that is the copper 2 plus by copper, right? So we will write the right hand side, this is the R for right hand side, redox potential, reduction potential. Okay, so the right hand side reduction potential would be E0 of right hand side, that is the copper 2 plus by copper, so E0 of copper 2 plus by copper, right? Okay, so now minus E0 reduction of left hand side. Okay, so E0 reduction of left hand side, what is the left hand side? This is a zinc by zinc 2 plus, but we have to write this term in a reduction pathway, right? Because this E0 reduction, so we will write E0 zinc 2 plus by zinc, not zinc by zinc 2 plus, কারণ আমার এখানে দেওয়া আছে E0 reduction of left hand side, আর এখানে আমি যদি জিঙ্ক বাই জিঙ্ক 2 প্লাস লিখে ফেলি তাহলে সেটা হয়ে যাবে অক্সিডেশন পোটেনশিয়াল, কিন্তু এখানে আমায় দেওয়া আছে রিডাকশন পোটেনশিয়াল অফ লেফট হ্যান্ড সাইড। এই রিডাকশন পোটেনশিয়াল অফ লেফট হ্যান্ড সাইড আছে আমার জিঙ্ক বাই জিঙ্ক 2 প্লাস, কিন্তু তার রিডাকশন পোটেনশিয়াল লিখতে বলছে, তার আমি করব জিঙ্ক 2 প্লাস বাই জিঙ্ক। And if the term is given if the value is given in terms of oxidation potential, we can convert it in the reduction potential. আর যদি কেউ অক্সিডেশন পোটেনশিয়ালি সেটাকে লিখতে চায় তাহলে এটাকে করা যেতে পারে, সেটা হচ্ছে E0 oxidation of left hand side minus E0 oxidation of রাইট হ্যান্ড সাইড, বাট আমার সাজেশন বলবো যে এটাকে ইউজ না করাই ভালো, বিকজ নাওয়াডেজ ইট ইজ নট অ্যাকসেপ্টেড ইউনিভার্সালি। এটা কিন্তু কোনো ভুল নয়, বাট এটাকে অ্যাকসেপ্ট এখন করা হয় না। তাই আমার মতে হচ্ছে তোমরা E0 রিডাকশন অফ রাইট হ্যান্ড সাইড মাইনাস E0 রিডাকশন অফ লেফট হ্যান্ড সাইড এই টার্মটাকে ইউজ করো। E0 রিডাকশন অফ লেফট হ্যান্ড রাইট হ্যান্ড সাইড মানে কি, রাইট হ্যান্ড সাইডের আমরা রিডাকশন পোটেনশিয়ালটাকে নিচ্ছি, আর E0 রিডাকশন অফ লেফট হ্যান্ড সাইড মানে কি, লেফট হ্যান্ড সাইড মানে জিঙ্ক বাই জিঙ্ক 2 প্লাস এই টার্মটার আমরা রিডাকশন পোটেনশিয়াল নেবো। তাহলে E0 অফ জিঙ্ক 2 প্লাস বাই জিঙ্ককে আমরা নেবো। তাহলে ওভারঅল যখন আমরা E0 সেল আমরা পেয়ে যাব, E0 সেল যেই পেয়ে যাব, দেন উই উইল ক্যালকুলেট ইট অ্যান্ড উই উইল ডিটারমাইন whether it would be positive or negative, and if it would be positive then it will give del G0 as negative, if it is negative then it will give del G0 as positive. Now if del G0 is negative then it would be a spontaneous process, and if del G0 is positive then it would be a non-spontaneous process. So through this E0 cell calculation we can say whether the process would be spontaneous or not, and or whether the reactant will be converted to product or not. Okay, so this is basically the overall step 1, step 2 and step 3. So in the next slide we will go through some application, or we'll go through some mathematical application, and the picture will be much more clearer to you. তাহলে এখানে দেখো একটা প্রথম প্রশ্ন আমরা দিয়েছি যে ক্যালকুলেট দ্য E0 সেল হুইচ ইনভলভ দ্য ফলোইং রিঅ্যাকশন। তাহলে রিঅ্যাকশনটা আমার অলরেডি দেওয়া আছে, তার সাথে দুটো ডেটা দেওয়া আছে, দ্যাট ইজ দ্য রিডাকশন অক্সিডেশন পোটেনশিয়াল অফ জিঙ্ক বাই জিঙ্ক 2 প্লাস সিস্টেম and oxidation potential of this silver by silver plus system, and comment on whether the reaction will occur or not. So we'll do the first step, right? So first step was to draw the redox reaction in a proper way. So the redox reaction is the ionic form zinc by 2Ag plus, which is being converted to zinc 2 plus plus 2Ag. So what is the oxidation process? The zinc is being converted to zinc 2 plus. This is basically the oxidation process, and this Ag plus is being converted to Ag. This is basically the reduction process. So what the step 1 has been completed. Okay, so now it would be a step 2 to draw the electrochemical cell in a proper way. So middle one would be the salt bridge. The right hand side is the reduction process, right? So what is the reduction process? This Ag plus is being converted to Ag, and we will write these in such a way to represent it as a reduction process. So Ag plus by Ag, right? We will not write as Ag by Ag plus, we will write as Ag plus by Ag, and the left hand side would be the oxidation process. So the oxidation process will be zinc by zinc 2 plus, right? We will not write zinc 2 plus by zinc, we will write as zinc by zinc 2 plus. So this is basically the step 2. So now we will write the step 3. So the step 3 is that E0 cell calculation. So E0 cell is, what is the E0 cell calculation? That is E0 reduction of right hand side minus E0 reduction of left hand side, right? So in the right hand side it is the Ag plus by Ag. So Ag plus by Ag is basically the reduction term. So it would be E0 of Ag plus by Ag, and the left hand side is basically the zinc by zinc 2 plus, but we should write in the reduction term, or in the term of reduction potential. So basically we will write E0 of zinc 2 plus by zinc, not zinc by zinc 2 plus. I think it is clear to now. So now we have to calculate this one. So what is the value of E0 of Ag plus by Ag? The term which has been provided is actually the oxidation potential for the silver by silver plus, and for the zinc by zinc 2 plus. So what would be the reduction potential of silver plus by silver? Just the opposite of this oxidation potential. So oxidation potential is minus 0.8, the reduction potential would be plus 0.8, right? So it would be plus 0.8 volt, and now this would be minus, and what would be the potential of this zinc 2 plus by zinc? It would be the opposite of the 0.76, so it would be minus 0.76 volt. Okay, so overall it would be a positive term, and it would be plus 1.56 volt. See, this unit is very important. You have to write the unit properly, and if you don't write the unit then the marks will be deducted. Okay, so now we have got that E0 cell. So this is the final conclusion, that we have got the E0 cell is positive. Now if it is positive, so as per the equation del G0 equals to minus NFE0 cell, so it would be a negative term. So as it would be a negative, so the process would be spontaneous. Okay, I think that you have already understood the overall math. So step 1 was to draw the redox reaction properly. Step 2 was to draw the electrochemical cell properly, and step 3 was to calculate the E0 cell in the proper method. And when you have calculated the E0 cell, then you have to explain whether the reaction would be a spontaneous or not, or whether the reaction will occur or not as per the equation del G0 equals to minus NA E0 cell. Then if E0 cell is positive, del G0 will be negative. If E0 cell is negative, del G0 would be positive. And through that method you can comment on whether the reaction will occur or not. So this would be our last example in today's class. And the question is whether the metallic tin will reduce tin 4 plus or to tin 2 plus. Okay, so now through this equation, through this term, you will have to write the equation. In the previous question actually the equation was given, but here the equation is not given, but through the statement you have to write the equation. So just try to consider the first line. Will metallic tin, what is metallic tin? Metallic tin means that tin where the oxidation state is 0. So metallic tin is reducing tin 4 plus to tin 2 plus. So therefore as per the question, this metallic tin is actually reacting with tin 4 plus, right? As per the question we are trying to reduce the equation. So now the metallic tin is reducing tin 4 plus means that metallic tin is reacting with tin 4 plus, and now the tin 4 plus is being converted to tin 2 plus. So therefore in the right hand side it would be tin 2 plus. Okay, now we have to balance the reaction. So in the left hand side, what is the total charge? In the left hand side the total charge is plus 4, and in the right hand side the total charge is plus 2. Again in the left hand side the total number of tin is 2, like there is 2 tin, and here it is 1 tin. So there will be another 1 tin, right? Another 1 tin atom or ion. So now the overall charge in the left hand side is plus 4, and the right hand side it is having plus 2. So in the right hand side more plus 2 charge should be there. So now if we are balancing this equation, there would be a Sn plus 2. Okay, I think it is clear to you. So the metallic tin that is tin 0 is reacting with tin 4 plus to be converted into tin 2 plus. Now when we are just balancing this equation, the left hand side is having 2 tin, so in the right hand side we are just having one more tin, that is 1 Sn. Now when just to balance the oxidation state, in the left hand side it is having total plus 4 charge, but in the right hand side it was having plus 2 charge, so the extra tin should have the plus 2 charge to balance the overall equation. Okay, so now the equation is balanced. So now we have to just determine what is the oxidation process and what is the reduction process to complete the step 1. Okay, so now what is the oxidation process? That is the tin 0 to tin 2 plus, right? And what is the reduction process? That is the tin 4 plus to tin 2. Okay, so this is the step 1. So now we will have to draw the electrochemical cell. So definitely there will be a salt bridge in the middle, and in the right hand side it would be a reduction process. What is the reduction process? That is tin 4 plus is being converted to tin 2 plus. So this is basically the reduction process, and we should write the process in such a way to show it as a reduction reaction. Okay, so now in the left hand side it is the anode where the oxidation process is being carried out. So what is the oxidation process? That is tin 0 is being converted to tin 2 plus. So we should write in such a way to show it as the oxidation process. So we will write it tin by tin 2 plus, not tin 2 plus by tin. So the overall this step 2 has been completed. What is the step 3 now? So step 3 is basically the E0 cell calculation, right? So the E0 cell means that E0 reduction of right hand side minus E0 reduction of left hand side, right? So what is the E0 reduction of right hand side? Right hand side means that tin 4 plus by tin 2 plus. So its reduction potential means E0 of tin 4 plus by tin 2 plus minus basically the reduction potential of left hand side. What is the left hand side? This is the tin by tin 2 plus, but we have to put the reduction potential. So basically this would be E0 of tin 2 plus by tin. So আমরা কি বলছি, আমরা left hand side এ কোনটা আছে, tin আর tin 2 plus, কিন্তু লেফট হ্যান্ড সাইডে আমরা কি নেবো, রিডাকশন পটেনশিয়াল নেবো। তাই আমরা কিন্তু লিখছি E0 অফ tin 2 প্লাস বাই tin। আমরা কিন্তু একবারও লিখবো না যে tin বাই tin 2 প্লাস। tin বাই tin 2 প্লাস লেখা মানে কিন্তু সেটা অক্সিডেশন পটেনশিয়াল হয়ে গেলে এবং অঙ্কটা ভুল হয়ে যাবে। তাহলে ইকুয়ালস টু আমরা কি করবো, এবার দেখবো আমার গিভেন কি দেওয়া আছে, সেগুলো কি দেওয়া আছে দেখো। tin 4 প্লাস বাই tin 2 প্লাস এখানে দেওয়া আছে, তাহলে এখানে আমার কোনো প্রবলেম হচ্ছে না। তাহলে আমি 0.15 ভোল্ট লিখলাম। মাইনাস হচ্ছে এখানে রিডাকশন পোটেনশিয়ালটাই দেওয়া আছে, তাহলে আমি বসাবো মাইনাস অফ মাইনাস 0.13 ভোল্ট, সো অল ওভার ইট উড বি 0.28 volt. Now the last section is E0 cell is positive. Now if E0 cell is positive, then del G0 equals to minus NF E0 cell, right? So it would be a negative term. So as it would be a negative term, then definitely the process would be spontaneous. So the comment would be that definitely metallic tin will reduce tin 4 plus to tin 2 plus. So as the process is spontaneous, then definitely the metallic tin will reduce tin 4 plus to tin 2 plus. Okay, so in this class we have already learned so many things. So first is the redox reaction. What is the redox reaction and how to write a redox reaction in a proper way as per the ionic term. So this was a step 1. In the next step we have already seen that how to draw the electrochemical cell in a proper way. That is, in the middle this is the salt bridge, in the left hand side it would be a anode where the oxidation process is being carried out, in the right hand side it would be a cathode where the reduction process is being carried out. Okay, and this was a step 2, and in the final step, what is the step, which one is the step 3? It was the E0 cell calculation, that is E0 reduction of right hand side minus E0 reduction of left hand side. We are calculating through the reduction potential, not through the oxidation potential. Oxidation potential নিয়েও তোমরা ক্যালকুলেট করতে পারো, সেখানে কোনো প্রবলেম হবে না, কিন্তু আমার এখানে সাজেশন ছিল যে অক্সিডেশন পোটেনশিয়াল অ্যাকচুয়ালি ইন জেনারেল অতটা বেশি এখন ইউজ হয় না এবং অ্যাকসেপ্টও অতটা বেশি এখন হয় না, তাই রিডাকশন পোটেনশিয়াল নিয়ে কাজ করাই ভালো এবং একটা মেথড শিখে রাখাই ভালো, তাতে ভুল হওয়ার চান্সটা অনেক কম হবে। ওকে, তাহলে আমরা E0 সেলও ওখানে ক্যালকুলেট করলাম। তাহলে E0 সেল আমরা ক্যালকুলেট কেন করছি? কারণ থ্রু দ্য ক্যালকুলেশন অফ E0 cell we know that del G0 is related with that E0 cell as per a minus NF E0 cell. So if E0 cell is positive, then del G0 would be negative and it would be a spontaneous reaction. So through the calculation of E0 cell we can comment on whether the reaction would be spontaneous or not, or whether the reaction would be occur or not. Okay, so thank you very much for watching this video, or thank you very much for this class. If you have any doubt still regarding this class, you can contact us directly at NS Institute through the website www.nsinstitute.com, or you can drop us a mail at nsinstitute@gmail.com, or you can directly call us in the given number. Thank you very much for watching this video.